So what we have here is just the initial view. And of course it shows as when I showed this right away to Josh, he said, oh, look, the advertisement. So of course they're promoting their app, which is something you pay for. I didn't check the price of it. I don't think it's very much money. Usually these apps are not much money. And I know we're used to getting things free online now, right? So if somebody charges you $3 for some useful app that you'll use for 10 years, you think, $3? But of course you waste $3 or $4 on cups of coffee all the time. So they've got the settings, the planets tonight. You can explore that a little bit later. They don't have tons of information. Well, I guess I can show you the planets tonight. It just gives you a map here of the time. So the dark is when it is dark out, of course. And then the light is the daylight. So just at a glance, you can see what planets are visible in the evening, what planets are visible through most of the night, and what planets are visible in the morning. And we will look at those as well. So you can see now, I have this set for today at 8 o'clock tonight. Most of the planets that are visible will be visible in the morning. Only Venus is visible in the evening, and you can barely see Venus in the background right there. But I'm going to click these little 3 lines and make this disappear. This is a fairly new application. Stellarium is old, but the web app is fairly new. So they're still working on functionality. The search was a little bit glitchy, but I'm going to go through all the aspects of it while I give you the tour of the sky. So it's kind of a tour of the sky and a tour of Stellarium web as well. So you can see in the upper corner here, observe, and that's kind of a mystery. I didn't know what that meant, but this was actually promoting their little virtual logbook too. We're not going to do anything with that, but it's a way that you can make note of your real sky observations and share those with others and look at other people's real sky observations as well. There are many other tools to do that as well, such as pen and paper. Ooh, when was that invented? But other collaboration tools, you can use a shared Google document or Office 365 document as well. So you see a few buttons. Oh, and by the way, down here, this is your location. Still working on that. Turns out we live in Null, United States of America. So some kids that grow up here think, yeah, it is kind of Null, kind of a boring place, but it's not, because it has our university. Over here, you can see the time. This is military time, 24-hour clock. So I've got it set for 2000 hours or 8 o'clock tonight and today's date. So these buttons, as you hover over them, it will show you what you can see. And when it's lit or when it's white like that, then it's activated. So constellations aren't activated. If I click on that, you can see the connect the dot constellations. Constellation art. So those are some of the drawings, and those are actually one of the same sets of drawings we have in our portable planetarium on campus, because that portable planetarium uses a type of, or maybe the sister to Stellarium software, Atmosphere. So right now I've got it set for 8 o'clock, and we know at 8 o'clock tonight, the sun has set, but it's not pure black. But if we turn off the atmosphere, then we will indeed see that all the stars, everything that could be seen is seen. And it's not really the atmosphere that blocks us from seeing things in outer space, aside from the super bright objects during the day, the sun, the moon. When it's fairly bright out, you can still see Venus. It doesn't have to be super dark for you to see Venus. But the sun lights up the atmosphere. So it's not the atmosphere itself, and it's not the sun itself either. If you're on the moon, which has virtually no atmosphere, and you just put your hand up in front of your face to block the sun, you can still see stars all around your hand because there's no atmosphere being lit up. But I want it to look like it would normally look because it's actually important, I think, to start your viewing when it's fairly light out if you're new to viewing, because then you're not lost by all the points of light. Landscape. So we can get rid of land, but that's not very realistic. And then a few different types of grids. We can measure degrees up from the horizon. So it's called an azimuthal grid. North is, this doesn't have that many numbers on it. North is 0, and then it goes through east and south. So east is 90 degrees azimuth, south is 180, west is 275. And then you can measure up degrees from the horizon. So you can see near the upper right and the upper left, this positive 20 degrees. And really tucked in the corner here, I see one number. I guess at the top, I can see the numbers here. So 315, 300, and so on. So there's the 270 for west. Equatorial grid, that is measured with respect to the celestial equator. That color is a little bit more difficult to see when it's light like this. We're not going to touch on those very much. So this is deep sky objects, the thing that Deanna said looked like a tornado. And if I flip that on and off, not much seems to happen. I don't really notice anything happening. When it gets darker, we will check that out. Node, not a big deal now, but if I click on this, you'll notice it becomes red. So think a little bit, why is night mode red? It turns out that red does not harm our night vision. So if we take our computers outside, and pretty much every app that I've seen on a phone too has a night mode. So if you're outside viewing and it's super dark, you don't want to your night vision to even just this level of, well, if you're out in the middle of the night, you're not gonna have this background light. But even at midnight, if the moon's out, that's gonna illuminate or excite some pixels on your screen. And that could be enough to hinder your night vision a little bit. So red does not affect that as much. And then finally, full screen. So let's go to full screen. And then Stellarium tells me that I'm at full screen. All right, so if we just move around the horizon a little bit, you can see we're looking west and you've got that blob of light from the recently set sun. A lot of people point out, oh, that object, that really bright object in the western sky, that is Venus. And recently Venus got as far from the sun in the nighttime sky as it will be this cycle. So the last few weeks and the next few weeks are when Venus will be farthest from the sun in the sky, making it really easy to see. Venus, I've read, is the most it's the most mistaken object for a UFO because it's so bright. It's the brightest point of light it's the brightest natural point of light that you'll see that is constantly occurring. Some supernova, which are fairly rare, they could get brighter than Venus. There are a few human-made objects that if they catch the sun just right can be brighter than Venus too. But Venus is always 99.9% of the time going to be the brightest object that you can see. So if we zoom around here, you can see a few other points of light. And as it gets clearer, we will check those out and see if those have names. We could click on them now, but I don't want to ruin the plot. So now we're looking south and we see, again, this is for tonight's sky. So we've got the moon high in the southeastern sky. And we go all the way around. Here's another fairly bright star. Here is our barn. Here's the north. And we're just going to come around to the west again. So not a whole lot to see. If we look fairly close to straight overhead, we see a few points of light. But let's make it get a little bit later. So I can click on this. And you can see there's the pause, unpause button. I actually have time paused right now. And I can click this and go back to the current time, but I don't want to do that. I'm going to step forward 2 hours to 2200 hours. It doesn't seem to want to click to that next hour for some reason. There we go. So now a whole lot more to see. Let's go back to Venus again, because Venus there now looks like a giant blob of light. Venus, of course, in the real sky is not going to look like a giant blob. Usually in these programs, and also on static paper maps too, the brighter the object is, the bigger the blotch. So on a piece of paper, of course, the paper will be white and the blotch will be black almost always. It'll be a big black dot, meaning something is darker. In the nighttime sky, much, much brighter objects do look a little bit bigger, but the brightness and the size really has very little relationship. But this is just a representation. So Venus looks like it's this big blotch, but if you look here, it looks like it's hiding something. So let's zoom in and see what indeed it is hiding. So as we zoom in, I'm going to zoom in to, let's see, about what would be a large field, binocular field of view. You can see in the upper right-hand corner, FOV stands for field of view and 6 degrees. By the way, if you want a good sense of what that means, if you make a fist and hold your fist at arm's length from the pinky side of your fist to the thumb side of your fist, if you hold it out at arm's length, that subtends an angle of about 10 degrees. And your fist isn't perfectly symmetric, but your fist roughly held out at 10 degrees makes a circle, or your fist held out at arm's length makes a circle about 10 degrees in diameter. So 6 degrees, that would be roughly half of your fist. So this is actually an interesting time. Venus, being a planet, does not remain in the same part of the sky with respect to the background stars. Just so happens the last few nights and the next few nights, Venus has been near Pleiades, which is an open star cluster. And I know that because I've read about it, but if I click on it, I get some information. So let's talk a little bit about this information. And they take this information from Wikipedia. It's printed really small depending on how you're watching this. You might not be able to read it because it's going through the video, so that's making it a little bit more pixelated. But let me just go through a few of the bits of information here. So the Pleiades, that's its common name. It's an open star cluster, which means it's a star-forming region. These are very young stars, and by very young stars, I mean about 100 million years old. So you think, wow, 100 million years, that's not very young. Our sun is about 5 billion years old. Some stars can live tens and hundreds of billions of years. And it depends on what you mean by live, of course, but some stars are in the prime of their life for many, many billions of years, tens, hundreds of billions of years. So these stars, by that respect, are very young. Some of the other names of it, also called the Seven Sisters. You can sort of see it from this view. It's kind of this cup shape. It's also known as Subaru. If you've got a Subaru automobile, or if you know somebody who has one, and this is a college town, so lots of people have Subaru automobiles. This is very similar to the symbol on the front of a Subaru automobile. And the rest of these are names from different catalogs. Magnitude 1.59. The magnitude is a measure of the visual brightness as seen from Earth. The smaller the number, the larger the brighter it is. So 1.59 is actually a fairly bright object. The Pleiades is very easy to see in the nighttime sky. Its size 110 dash by 110 dash, so that means arc. I don't know if this is a dash, apostrophe maybe. This is 60 arc minutes in a degree. So this is the sign for an arc minute. So 110 arc minutes by 110 arc minutes, that's about 1.5 degrees by 1.5 degrees. So that might be, so I talked about your fist held out at arm's length is about 10 degrees in diameter. Maybe if you could curl your thumb and hold that out at arm's length, that would roughly be the size of the Pleiades. Orion deck, that is just the coordinate system in the sky, similar to latitude and longitude. So that's an absolute measure. Just like your house is at a given latitude and longitude, and it doesn't matter where you're describing that to. You can be telling that to your next door neighbor, you can be telling that to your friend across the country. That latitude and longitude is going to tell them exactly where you live. Similarly with right ascension and declination, that will tell someone exactly where the object is in the sky. As and alt, that's the azimuth and the altitude, that is dependent on your location. You might see something high in the sky, which means it has a high altitude, but your friend living elsewhere in the world might see it at a low altitude. So that is location dependent. And then visibility when it rises and sets, and then just information down here. So I mentioned that magnitude, the smaller the number, the brighter it is. So I'm going to click on Venus. So before I do, think about what Venus's magnitude would be. The Pleiades was 1.59. I said smaller numbers are brighter. So let's think about that for a second, and I'll click on Venus. Venus is a planet. Its magnitude, well, just at a glance, you see 4.32. That's a bigger number than 1.59, but there's a negative sign in front of it. So this has a negative magnitude. And that's an artifact from when this scale was first formulated by Hipparchus, an ancient Greek astronomer who lived maybe 2,200 years ago or so. He classified the stars according to a magnitude scale, but in his mind, magnitude meant important. So people who are of high magnitude, of high importance, they're people of the first magnitude. The next level down, maybe sort of the vice chairmans and that sort of thing, the directors, they're of second magnitude, then third magnitude. So it was very qualitative. More recently, people have made it more mathematical, a logarithmic scale, where a difference of 5 magnitudes, so from 0 to 5, is a brightness ratio of 100. So something that's magnitude 5 is 100 times brighter than something that is magnitude 0. So this has the distance, so 0.62 astronomical units, and 1 astronomical unit is the distance between the Earth and the Sun. And the radius, or the size of it, sometimes it's hard to see the box when it's lined up with the star, so about 6,000 kilometers, got the RA in the deck. Phase, that's interesting. I don't know if we'll be, yeah, I think actually we can zoom in. Let's zoom in a little bit more when we're done with this box. So Venus has phases just like the moon does. So if we zoom in a little bit more, I think we're going to, yeah, I've never quite figured out how to center something here. But if we zoom in, it goes from being just a light blob to actually seeing a photograph of Venus and how it's lit. So notice here the field of view is 0.14 degrees, so that's about 1/6 of a degree. This would be a fairly powerful backyard telescope. There are people around that own telescopes that could see Venus with this quality, but not many. It would be a fairly expensive instrument to do this. Not prohibitively expensive for people of the first magnitude, but expensive. But you don't need a good telescope to enjoy the nighttime sky. And in fact, some things are best observed with binoculars. Like I said before, this is the typical binocular field of view. If we were to zoom in on the Pleiades, some of it we would gain some nice things about it, but some things that aren't so nice. So when we zoom in too much, we almost get this sea of stars and we get lost in the stars. So that's a downfall of zooming in. The plus side of zooming in is we notice this blue haze around it. Since these are young stars, they have not cleared out their area of the clouds of gas and dust from which they were formed. So the blue haze around there, that nebulosity, that is the gas and dust from which the stars were formed. So you're basically seeing sort of the birth material is still near those stars. As those stars age, they will get more active. They will have a more active solar wind. Our sun pushes particles out. Early in stars' lives, they have a stage that they are really aggressive. They push people away, kind of like teenagers, right? Get away from me, mom and dad. So stars go through that phase as well, but instead of get away from me, mom and dad, it pushes out that the clouds of gas and dust. So someone who's looking at our sun from this far away, and this is about 400 light years away, someone who's 400 light years from our sun would see a fairly crisp point of light. All right, so I'm going to zoom out some more. And I didn't want to zoom out quite that far. So if we zoom out some more to the left of it, you can see another, looks like a little arrowhead of stars. That's the Hyades. That's another open star cluster. That is an older star cluster. Those stars have spread out more, and they also don't have the nebulosity, the particles around them. Between the two, you see the word Vesta. Vesta is one of the asteroids. A few years ago, the Dawn mission visited both Vesta and Ceres, the two largest objects in the asteroid belt. Vesta, actually, let's just click on Vesta. So Vesta here has a magnitude of 8.43. It is something you definitely cannot see with the naked eye, even from the darkest site possible. It would be difficult to see in binoculars, but not super difficult. If you had a good pair of binoculars, and especially if you put your binoculars on a tripod or even a monopod, just a single stick pod, that adds a lot of stability. You could see Vesta with binoculars, a good pair of binoculars then. And if you look at that part of the sky from night to night, you would see that Vesta moves a little bit with respect to the background stars. So we zoom out some, go a little bit more towards the south. We can see one of the most prominent objects in the wintertime and early spring sky, Orion. Some of the things in Orion you may have heard about. Rigel is the brightest star in Orion. Betelgeuse is the second brightest star, but if you've been following the astronomy news lately, you may have read that Betelgeuse has been dimming quite a bit. And this little iconography shows Betelgeuse much, much brighter than Bellatrix. And yes, that's the same name, Bellatrix, that J.K. Rowling used in Harry Potter, Bellatrix Lestrange. J.K. Rowling took a lot of names from the nighttime sky. But anyway, Betelgeuse is a red supergiant star, and astronomers think that there are clouds around Betelgeuse that have been increasing, and that's what's leading to its dimming. They don't think it's something that's inherent in the star, that some internal to it is causing that dimming. But if we zoom in, so those are some interesting naked eye glance at it objects. There's the belt of Orion. But if we zoom into where it says on here, lower sword, and now we're at roughly ocular field of view. And by the way, your binoculars probably won't see it this rich, but we can see more nebulosity, and we can see that it's the image here is loading sort of slowly on the monitor. But that is the Orion Nebula. So the Orion Nebula is a star-forming region, and as the stars load, they seem to be forming as we stand here. But the Orion star-forming region is about 1,300 light years away. And I've tossed out that word light year, I think, twice. I guess those two words, light year. Light year is a measure of distance. It's the distance that light travels in 1 year. So something that's 1,300 light years away, the light left the Orion Nebula 1,300 years ago. So we are looking at old light. We're looking at 1,300-year-old light. And think about that. Whenever somebody says something is a certain number of light years away, you're looking at light that came from that object that amount of time ago. The nearest star, Proxima Centauri, is 4.2 years away. That light, when it reaches our eye, is 4.2 years old. And that's the case for everything. When you look at your neighbor, if you're sitting in the room with someone, they're 6 feet away. Oh, I actually should have done this social distancing calculation. But for someone who's 6 feet away, that light takes approximately 1 nanosecond or 10 to the minus ninth seconds to get to you. So you are looking at that person as they were about 1 nanosecond ago. So they actually have aged a nanosecond in the time that it took the light to get from them to you. All right, we zoom out again. And interestingly enough, when I looked at this yesterday, the exact same time, there was a satellite, a human-made satellite right here. So this also shows satellites as well. And there's a great website called heavens-above.com that I can put into the chat a little bit later. Let's see here. Let me do that now. And we've got some questions up there as well. While I'm putting this into the chat, let's just be super efficient. So you should see that. Oh, and we've got questions. Oh, well, it was a private question, but now I just showed it to everybody. So what is a supernova? Who is the Pleiades star cluster named after? And what's the brightness magnitude of the sun? So what is a supernova? I think I mentioned Betelgeuse is a star. If I didn't, I will now. Betelgeuse is a star that could go supernova. So the very simplest explanation of a supernova is it's an explosion of a very massive star. And the next level beyond that, because I know the person that asked that, they don't just want the simple level, want a more complex answer. And they also want an answer that involves bouncy balls, because everybody loves bouncy balls. So stars are held by two types of forces, and I'm using forces in the very generic sense. So stars have a lot of mass, and everything that has mass has gravitational pull. So stars are held together by their gravity, but they also radiate light. They have energy, they have heat. Things that heat up tend to expand. So there's that combination here. Gravity is tending to pull a star inward. Radiation, pressure, light is tending to push the star outward. For most of the star's life, those balance each other pretty well. But as a supermassive star ages, then the radiation pressure and the gravity don't balance each other very well. So there gets to be a certain point where the star collapses. And think of the collapsing point of the star as a bunch of people throwing a bunch of bouncy balls. They have really good aim. They all throw them towards the center of the room. Those bouncy balls hit each other, and then they bounce out all over the room. That's basically the supernova. There's that rapid contraction, and because all those particles then, it's a crude explanation, but bounce off of each other, they bounce outward, and the star doesn't completely fly apart, because what's left behind with the supernova is either a neutron star or a black hole. The Pleiades, so that is a great question. So the seven sisters, I believe Subaru means seven sisters in Japanese, but I'm not as up on my history. If someone wants to look that up and put the answer in the chat, that would be great. So the name, the Pleiades, I probably knew at one time bouncing around my head, but I'm older and senile now. And then the magnitude of the sun, it's about -26. So remember, Venus was -4 approximately. Pleiades was about +1. Betelgeuse, this will probably have the value of Betelgeuse before it's dimming, about 0.5. Now I think it's about 1.2 or something. Well, it's about the same as Bellatrix. So yeah, 1.5. But yeah, I think the sun, it's either -26 or -27. Let's zoom back out again. And the moon, well, here we'll get a big number for the moon for the magnitude. So that's -12.6, -13 right now. We've got the moon. Oh, and the moon, by the way, is next tonight. It will be next to the bright star Regulus, which is in the constellation Leo. So this is a good time to turn on the constellation lines. Leo is the lion. Leo is one of the zodiac signs. You can see Cancer, Leo, Virgo. Those are more of the winter timey, or well, Cancer, Leo, kind of the winter to spring constellations. We get into Virgo, we're getting into the spring constellations. By the way, to say that something is a blank constellation is to say that it is a constellation that is prominent in the spring sky. You can see spring constellations other times a year, but you maybe just catch them barely when the sun sets, or you catch them just before the sun rises. And then we can look at the picture. So you might say, I don't really see how that's a lion, but we've got this backward shaped question mark is the head of the lion. There's the body of the lion, the lion's tail. Then here we've got Virgo, dressed a little bit risque, I think, for a children's planetarium show, but we will censor that, right? Oops, took away the landscape. That's not censoring it. There we go. And as we zoom around even more, and now we get up a little bit, we see Ursa Major. So we see something that looks sort of Dipper-like, and it's pretty big. So when we see something Dipper-like that looks sort of big, we give it the name the Big Dipper. So Ursa Major here is the Big Dipper, sorry, makes up part of Ursa Major. Ursa Major is a larger grouping of stars. The Big Dipper in and of itself is not a constellation. It is what's called an asterism, or a group of stars. The constellation here, Ursa Major, is the Greater Bear, which we can see if we look at that, and there's that Virgo again. But if we take these two stars and the Big Dipper, so I like to count from the handle 1, 2, 3, 4, 5, 6, 7. If we take stars 6 and 7 and go to the next bright star, that is the North Star. And we can test that out. We see that the North Star is right above the N here for north. Before I move on farther, this is not a great place to see it because it's so low, but I do want to zoom in on this shape here. This M31 is Messier. Charles Messier was a French astronomer that lived around 1800. He cataloged a bunch of different objects that looked like comets but weren't comets. So this is the 31st thing in his catalog. And as we zoom in, we see that that is definitely not a comet. That is a galaxy. This is the Andromeda Galaxy, which is our nearest neighbor galaxy. At 10 o'clock at night, you can see it's pretty low to the horizon. Galaxies, comets, which I'll talk a little bit about a comet later. Other objects, even open star clusters, are difficult to see near the horizon because you're looking through a thicker part of the atmosphere. There's more light pollution. And also, there's a little bit more dust that's kicked up from the ground. But really, it's you're looking through a thicker part of the atmosphere when you're looking down low. The Andromeda Galaxy is our nearest neighbor giant galaxy. It's about 2.5 million light years away. When you look at the Andromeda Galaxy, you're seeing light that's 2.5 million years old. It's larger than the Milky Way galaxy, depending on if you're measuring the mass of it or the number of stars, but it's roughly 50% larger than the Milky Way galaxy. The Andromeda Galaxy and the Milky Way galaxy are gravitationally bound to each other, and they're actually moving towards each other. And in about 2 or 3 billion years, that's billion with a B, they will collide with each other. And when galaxies collide, it's not like two balls colliding. With galaxies colliding, there are very few, maybe even 0 star-to-star collisions. They sort of pass through each other like 2 swarms of bugs, but they gravitationally interact, and what the result will be after the collision is complete will be a big sort of amorphous elliptical shaped galaxy. But let's move ahead a few days at a time. So I'm going to turn on the constellations and I'm going to go south to southeast here. And let's just see what happens as we go forward in days. And actually, yeah, we're going to keep going forward in days. So notice the moon was zipping across the sky. So the moon shifts its position noticeably from night to night. And notice the constellations move a little bit away from the east. So the constellations rise about 4 minutes earlier each day. So that is why we get the different seasonal constellations, because at this time before we didn't see any of Libra, now we can. We didn't see any of Serpens, now about a week later we can, although Serpens is pretty dim. But if we just zip through here, I'll skip to May 4th, and so a few others. There's Ophiuchus, Hercules, we didn't really see very prominently before. I'll skip ahead 1 month. We can see Aquila, Cygnus, and Lyra. And I want to highlight this. I'm going to turn these off to make it a little bit easier to see. So these bright stars here, here, and here, this is Altair, Deneb, and Vega. They make up the summer triangle. So notice this triangle is rising. It's about 10 o'clock at night. That's roughly an hour after sunset. So as the sun sets, so let's just go back an hour here, and the sky will be pretty light. We can barely see it. But those, we can barely see those stars. But those stars are rising now, and we'll go back to the 10 o'clock time. This is heralding the start of summer. So this is called the summer triangle. You can see it other seasons of the year, but it rises as the sun sets when summer starts. The sky is our original calendar. So a lot of like the spring constellations, those constellations were up during the time that you should plant. The fall or the autumn constellations, those constellations are above the horizon the time that you would harvest. The summer triangle, when those bright stars are rising as the sun sets, we know that summer's coming, the hottest time of the year. So I'm going to go back to today again. And we're going to go to the east. And let's just go, let's pretend we're not sleeping very well. So we go to 11 o'clock at night, 12 o'clock at night. Antares, that's another red supergiant. That's another star that will go supernova, have the rapid collapse and then the outward pushing of the particles, the explosion, if you want to call it that. Excuse me for coughing. Or just the outward rushing of particles. So 3 o'clock, not too much exciting stuff. Ooh, 4 o'clock in the morning. 4 in the morning came without a warning. And along with that came Jupiter, Saturn, and Mars. If you're an early riser, look in the east to southeast sky and you will see 3 bright planets. Jupiter is the brightest of these 3. Jupiter is typically the second brightest planet after Venus. In some orientations, Mars can be a little bit brighter than Jupiter, but most of the time Jupiter is the brightest. So let's zoom in again and get to our sort of wide-angle binocular field of view. So depending on what size binoculars you have, you can almost fit all 3 of those planets in your binoculars. But let's zoom into Jupiter even more. And again, I need to practice my zooming in. So you can see a few things are being named here. So we'll zoom into a pretty good backyard telescope field of view. Callisto, Europa, Io, and Ganymede. Those are the 3, why did I say 3 and I just said 4 things? Those are the 4 largest moons of Jupiter. Ganymede is the largest moon in the solar system. Titan, which is one of Saturn's moons, is the second largest. And then comes Callisto, Europa. Oh, no, I'm sorry, Callisto, Io, our moon, and Europa. So 4 of the 6 largest moons in the solar system are these 4 moons right here. They were discovered by Galileo in about 1609. And you can see, if we zoom in to Jupiter, you can see these bands here on Jupiter. Jupiter has cloud bands just like the Earth does. The Earth's cloud bands aren't as noticeable because it is not perpetually cloudy like Jupiter is. So if we go over to Saturn, Saturn, of course, you think of that as the ringed planet. All of the gas giants have rings, but Saturn's rings are the most prominent, and they're the only ones that can be seen easily from the Earth. So here's Titan. I said that was the second largest moon in the solar system. The rest of these moons that have names, those are moons that are roughly the size, maybe the size of Washington State approximately. So they're sort of large to medium state in size. Titan, like I said, is larger than our moon. So Titan would be larger than the United States if it was spherical. And then we can move forward to 6 o'clock, 7 o'clock, and now we've got, actually at 6 o'clock we would have had 7 o'clock we would have had the sun up, but now we can answer the question of the magnitude of the sun. We can see how close it was. Okay, I said 26 or 20, negative 26 or 27, so negative 6.7, so between those two. Very, very bright. Alrighty. And sometimes I get the little chat bar that shows up. Sometimes I don't. I definitely get it if somebody asks a question. So Josh or Deanna or Kamina, if you could just type something into the chat, then I think it'll pop up for me. And I'll keep my eye on it. I'll go back to time, and I could stop sharing, and then I definitely see it, but I don't want to do that. Too much jumping around. Up, there we go. Okay, so here we go. So thank you, Josh. The Pleiades derives its English name from Greek legend, the Pleiades. Okay, so I wondered if they're the 7 daughters of the Titan god Atlas and the ocean nymph Pleione. So yeah, some of these myths, you gotta watch them a little bit. We've got sea nymphs, we've got Virgo dressed somewhat risque. So speaking of watching things out, when will our galaxy collide with the Andromeda Galaxy? And when will it collide? That is a pretty deep question, because when one ball hits another, when one car hits another, it's pretty clear they weren't colliding, they were colliding. When galaxies collide, both the Andromeda Galaxy and the Milky Way Galaxy have an outer, well, there's the dark matter halo, there's a gas halo. Those are obviously going to touch each other first, and then the thicker star regions will interact with each other, then the cores will interact with each other. So different models have it differently, and again, what exactly is the start of the collision? So I usually say 2 or 3 billion years with the B, and we, even 6-year-olds, will not be around then. Will humans be around then? Well, that's a good question. I mean, if I had to say yes or no right now, I would say no, because if you think of what Earth was like 2 billion years ago, Earth formed about 4.5 billion years ago. And it was pretty much bacterial life for the first few 100 million years. It was no life, but maybe 500 million years into it, cyanobacteria. but trilobites weren't around, so multicellular things weren't around for quite a long time. So a billion humans that would be virtually unrecognizable from today's humans, maybe were around 100,000 years ago, maybe pre-human species. I saw there's a earlier former anthropology professor, I think, joined in. Maybe I didn't catch that. But somebody here who knows about anthropology, they could talk about where sort of modern humans came about. But yeah, a billion years ago, there was nothing human-like and nothing mammal-like around. So the life that is on Earth, if there's any life on Earth, then will look quite different from what it looks like today. So what else do we have here? Have any collided galaxies been identified? Yeah, so there have been a lot of galaxy collisions. Now, just like we don't know when a collision starts, if we're unsure of what the actual starting point of the collision would be, that must mean the collision takes a long time. So with a car, you slow down, and you've seen the crash test videos where they'll slow it down and it'll show how the engine compartment just completely collapses. But in modern cars, the passenger compartment of the car stays in really intact, good condition. So they slow that video down and maybe it takes a few hundredths of a second. So that collision seems instantaneous when you're witnessing it from the sidewalk, but it's not instantaneous. Galaxies colliding happen in over a much longer period of time, but not the 13.7 billion years of the observable universe. They're the blink of an eye in that. So a human cannot see, a human lifetime is not long enough to see the entire galaxy collision. But if you go online, you can search for galaxy collisions, and usually with galaxy collisions, they're really gravitational interactions. So when you see offshoots of lines of stars, that is something, that's the result of the galactic collision. So that, in the analogy to that with cars, would sort of be like the windshield popping off. And you know, with modern cars, windshields are super safe. They don't shatter like if you drop a glass, but your windshield will get all crackly and then it might pop out of its holder. When you see galaxy collisions, you might see a stream of stars shooting out of it. That's analogous to your windshield popping out of its frame, or maybe some part of the engine kind of shooting upward because it's designed to deflect upward rather than deflect towards you. Let's see, other questions. So what if just one person was alive and it happened, the galaxy collision? What would it be like for them? So what would it be like for them? That is a great question. So what it would be like if someone lived a super duper long time. Oops, let's go back to that. So if someone lived a super duper long time, what it would be like, and not just living far in the future, but living a billion years. And my computer's kind of slow. Oh, so here you see this streak going across. This program will simulate shooting stars. So it can't predict the exact trajectory of a shooting star, but that's simulating a little rock burning up in the atmosphere. For the person who's alive, they will basically be seeing this galaxy getting larger and larger in their night sky. So if you could speed up the video, that's what you'd see. And pretty soon, this, of course, you see this white glob on your screen. That isn't what you'd actually see. As it got closer, you'd see stars that don't look super distinct, but you definitely see something more resolved than this. This white blotch is just an artifact of us zooming in on a photograph on a computer screen. You also see some galaxies near the Andromeda Galaxy. The Milky Way galaxy has some small galaxies that orbit it, as does the Andromeda Galaxy. I think when I was zooming out, I saw a human-made satellite. One last thing that I want to talk about, because we're almost at 1 o'clock. Oh yeah, so that's weird why I didn't see it before. So right above Betelgeuse is, so Cosmos 1953, an artificial satellite, also known as NORAD 19210. But that heavens dash above that I put the link to in the chat, that will predict the trajectory of many different satellites. So you can, and also the International Space Station. So if you want to see the International Space Station, you can go to heavens dash above and it will tell you when to find it. Or you can go outside at night, see a satellite and say, oh, that was really bright. I wonder what that was. Go to heavens dash above and it will tell you most of you're thinking, oh, did I just catch a spy satellite? Most of what you see zipping across the sky is just space junk.